Hi everyone, good afternoon. So glad to be here and welcome to the talk. And hope you had a fantastic time so far. Um, I'm going to apologize to you for something. I was here for the previous talk. Unfortunately, I didn't bring any Legos to distribute. So something I learned from the previous talk. So I think I will kind of consider it for my next talk. Um, so my name is Sheen Brisals, and I'm working for the Lego Group. I'm based in London office, and I'm active in the serverless community. So I have a bit of recognitions. I do blog posts and talks as well around serverless. Basically, sharing the experience that we've been through at Lego Group. So that's me.
And I'm Luke. I'm a lead engineer at the LEGO Group, nowhere near as famous as Sheen, but I'm an AWS community builder, which is like the lower league version of the serverless heroes. If anyone's interested in that, becoming a community builder, then definitely come and chat to me. It's a really, really cool program. And I lead, did I say I lead the payment squad at LEGO? At LEGO, so that's what I'll do. And I'll come back on in a little bit and talk about some use cases that we have.
Thanks, Luke. Okay, so this is the front page of LEGOcom. The good thing about speaking in Denmark is I don't need to talk about Lego or the Lego Group or the company or anything. Everyone knows better than me, of course. So one of the things that people ask me when I say, we move to serverless, we operate on serverless, is how much of this side operates on serverless? So I explain them all the time that when you go through your checkout journey, so you pick up things from the product and put in the basket, and you go through the checkout process and you do the complete, the completion of the checkout. So behind the scene, everything that handles your product validation, your payments processing, and the final order checks and everything else handled by serverless microservices. So that happens behind the scene, behind the browser. There is a BFF layer which acts as the backend for front-end layer, and then all the services behind are 100% serverless. So what we are sharing today is basically how we got to serverless, and then certain principles and practices that we kind of put in place and also learned along the journey. And then we will focus on development, operating side of serverless. So that's where Luke will come in and share one of the microservices they're building and how, the approach they're taking. And we will close up with keeping up with serverless. But if you are familiar with serverless, irrespective of whichever cloud provider, you know that it's an evolving technology, it changes all the time. New features, new services are coming out from everyone, AWS, Azure, GCP, etc., etc. So when you adopt serverless, how do you keep up with all the changes that happen? So that's the last part that we will be going through. Okay, so going into serverless, that's kind of the journey where everything starts. Now, every microservice talk, you hear about something. What is that? Every microservices talk always has this one particular guy, the villain, which is the monolith, right? So that's where the journey starts. So obviously we had a monolith few years ago, which was our previous, the legacy e-commerce platform. And this is actually basically a modified version of it. So it went through certain makeovers. So you see that API around the middle part. So that was some kind of beautification that happened to the legacy platform when we moved out of the JSP those days. Now the problem is that with APIs, you need to have an API gateway. So that's where the API gateway in place. This is nothing to do with the cloud API gateway. This was as a different provider, and then the front end was on AWS. Now, so this was there, and it was still a monolith. The problem was those days, typical delivery or deployment process onto production was a big occasion. So we had to group the servers onto different pools, And then we had to coordinate engineers across different locations and the teams. And they go through certain rituals. So they need to identify one pool. They need to drain the traffic. They need to then kind of, shut down the servers, release or do the release and test, and then, take it to production. I mean, the deploy and test and take it to production. Now, if everything goes smooth, it's fine. It takes an hour or two, so you move from one pool to the other. If something goes wrong as part of the deployment or testing, you start all over again, right? So that takes like 2, 3, depends on how complex the issue, et cetera, et cetera. Now, the stats here is actually a bug I tracked those days. I wanted to push something very simple to production, a simple info log to track a random production issue so that we get more visibility. You know how long it took since the bug was raised? Nearly 6 months before it went to production. Now, I can say that it's not always the case. Maybe this was kind of pushed down in priority, but this was kind of the situation. You think of the value stream attached to this, whole journey. You get the picture, right? So this is one area that we wanted to, get over. But still things continued up until one day, one Black Friday event. So Black Friday is when the peak of the traffic for e-commerce and everything. Everything was fine. These 3 boxes on the data center, they virtually sat next to each other in a data center in Denmark. Okay, and as the traffic peaked, the tax system gave up. Okay, and with that, it brought SAP out. Now, SAP was out. That means the Java, the application server, was hitting hard, and it exhausted all its connections and sessions and everything, threads and everything collapsed. So within few seconds, we started serving, service unavailable. It was down for more than 2 hours. I mean, you can imagine in a corporate world, the kind of, messages going up and down from the top and all sorts of, phone calls and things happen. So this was a reality. But at the same time, there were discussions around in the business stakeholders and the upper management that we need to change the platform, modernize the platform, because Lego had ambitions to reach out millions of children across different parts of the world. So they needed a better platform. So that also happening in parallel. But change was inevitable at this point. But the question was, where do we start? Because it's a huge thing. We can't play around with an existing working, e-commerce platform that is bringing millions and millions of, revenue. So where do we start? So, always you get the motivation, like everything starts with a single step, right? However long you walk, you just start with the first step. So that kind of motivation is fine, but we need to make a decision. There were too many options. So one was like, okay, let's buy something off the shelf. The problem is that then you would be queuing up to the vendor for every update or every feature you want to add. That takes days. So that you lose the innovative capability of your own people because you rely on somebody else. So that was out of the question. So then next was, how about a cloud version from the same vendor? Because that vendor they were promoting some kind of cloudified version, but then we realized it's just a wrapper and sugar coating, but it's not a real cloud solution. Now, the final option was, okay, let's do microservices, okay? Because that was like 2016, 2017 talk of the town, and everyone, microservices, of course. But how do we, develop, deploy, and run? So the obvious ones, like Docker containers, were so popular. And that brings your container management. Then someone asked, isn't that the whole thing that we wanted to avoid? With all the experience the bad experience we had, maintaining our own servers and all sorts of things. So that's where the momentum kind of shifted towards looking at a better option. At the same time, we were also modernizing certain, parts of the platform. We were looking at a headless commerce API based solution as well. So that's when the serverless, thinking and the talk started to happen. Also in London, the meetup and the community was slowly kind of, coming up alive. So me and others went through a few meetups and learned about serverless. But the big question that day those days was like, how do you use an ephemeral kind of serverless service mechanism to run a checkout flow? How do you maintain sessions? How do you take care of the user journey? So those were unknowns, obviously. And then, I mean, I spoke to people who were kind of early adopters of serverless, and they gave how they set up online wine merchant and so on and so forth on Azure and AWS, etc. So that gave a bit more confidence. But still, we can't simply knock everything down and go serverless. So that's where we wanted to experiment something simple to go with. So that brings us to what is serverless. I'm not going to spend too much, probably you're all aware. It's that, the compute model, we don't, manage servers and auto scale, highly available, and scale to zero, which is kind of a new to me that time, because when we think of scaling, we always think of scaling up, right? We never think of scaling down. So all these kind of good things. But for me, why we go serverless is more important than kind of the definitions of serverless, because often it's kind of misinterpreted like function as a service or Lambda function or issue function is serverless. No, it isn't. Serverless is basically an ecosystem of so many managed services that we incorporate to bring up a solution or build a solution. And then it has this sort of granular level control that we can gain with each managed service. And the other important aspect is like, if you think of the team culture, it brings the diversity. Like you no longer kind of a JavaScript or a Java programmer. You are kind of more than that. You learn about security. You learn about event-driven computing. You learn about queuing mechanism. So many other things come together. You kind of all of a sudden you are setting up your deployment pipelines. So that brings more into a team and also makes an engineer more diverse with the many skills. So that's another important aspect of bringing serverless or these sort of cloud modern technologies into a team. Now, so back to the story. So our first target was experimentation was to do something with the tax system. That failed. So by that time, we found that the same vendor also operated on a cloud-based SaaS solution. Because we were kind of, because it was sitting behind SAP, there were constraints, I couldn't reach out to cloud, it wasn't used. So we thought, okay, let's do something very simple. Let's bring up a serverless service, a simple service, an API and a function, which will reach out this cloud platform. And that's where the whole thing started. That was the first microservice, first thing we tried with serverless that went to production on LEGOcom. So I always say that if you're new to serverless, there are so many things that probably you need to worry about. So no one is going to make a start perfectly, okay? And don't wait for a perfect moment to make a start. Just make a start, and as you go through, improve it. So this is an important lesson that we learned during the early days. The rich man once said, speed matters in business. Easy for him to say maybe, but what is speed, right? Speed is, you say 50 miles is a speed or 20 miles is speed, all speed. So we were kind of forced into a speed situation here because with all the experimentation and the corporate world, the decision-making process delays and things, we were already delayed making a decision to move up to a newer platform. Now, if we miss certain targets, then there are, the license renewal fees and things, they will run into hundreds of thousands or even millions. So we were kind of up against a hard deadline. So which was around 10 months period from that point onwards. So that means if we kind of think 100 miles per hour is fast, then we had to run that speed for 10 months continuously. That was the challenge we had. So to give you a different picture, so this is a takeoff, right? So, you have the taxi and you kind of, your plane is waiting for takeoff. I'm not going to scare you, the air travel. But that's the start and that's the end, that 10 months, period. And now you speed up. Now, you can imagine that when you are on a takeoff track, when you reach that target, you don't have many options, right? You either take off. Even if you abort, it's not going to be a pleasant experience. That was exactly the situation, we were in. But we had a nice, buddy for company. This is Honey Badger. So this was the code name for that, the project. So the reason we chose Honey Badger is because Honey Badger is something that will smash through anything that comes on its way. So that's exactly the approach we had to have in order to succeed. So that's how it started. So spring 2018, this is roughly what we had as a single e-commerce team, a bunch of engineers, etc. And then we saw the first one went through. And then the following month, we brought more services, more serverless services. And we split in two ways. So we didn't want to touch the core checkout flows initially because that's the kind of money-making business, right? So we don't want to disturb. But we focused on the back-end processing services, so like a data processing that won't really, directly impact with the front end. So we had to work with a data pipeline processing flow. So for us, SAP still holds the source of truth for many things. So our challenge was to get the number of data feeds from SAP and take it all the way through the new headless commerce platform we had at that point. But still, as I said, the main thing was still on the legacy platform. So this happened, and for everyone's surprise, this, outperformed the existing legacy. So that means a feed dropped into that, the bucket, and then got updated in the other side, the commerce platform, faster than the legacy platform was performing. So incidents like this gave the stakeholders and the leadership team a bit more courage. Okay, let's try a bit more on serverless, and it seems to be kind of working and scaling, etc. So that happened, and the next month we put together the event streaming. So this is like if you're on a browser, you probably know that the Clickstream event. So as you go through your a web page, you click on many things. Everything is usually tracked behind the scenes. Which product you click, what you drop to the bucket, which payment option you choose. This is what we call the clickstream. So every move you make is all kind of watched. The thing is, it generates tons of events in the back. So in a busy period, for a minute, you're looking at millions of events. So that we built that kind of architecture, and we implemented the serverless flow of events. So the events go through various places like big data, data analytics, recommendations engine, so on and so forth. So that came in. And then now, end of November is Black Friday, right? So that came along. So this Black Friday, we put our first ever serverless microservices to test. Everyone was glued to the dashboard. And this is roughly, what it gave. As the traffic peaked, the serverless, the Lambda functions things, kind of new instances got, put in place. And it was beautiful to see for everyone that first-hand experience of serverless scaling. So that kind of kicked off the next phase. That's when we started to approach the core checkout processes, checkout service. I mean, I'm just showing the simplest architectural diagrams just to give a flavor. So they kicked off from there on, having done the first phase of our implementation or the migration. So the payment gateway came through. Payment gateway was so complicated those days because we had number of different payment providers: PayPal, Paymentry, Cardinal, UniPay, this, that, etc. And then different business groups, LEGOcom and other business groups across the Lego organization, they kind of have their own kind of integration. So it's kind of a completely messed up, tangled integration with the different payment providers. But still, we managed to do that and put that in place. And then someone worked on a workflow. I mean, it may look very simple, but first time someone doing serverless, it was kind of mind blowing. But the kind of the way they demoed those days, everyone was, oh, okay, this is possible, right, etc. But now it looks simple because you have the experience. So moved on, and so the reward generation. So if you're a VIP member, you know that you get vouchers and stuff. So it has a long process behind the scenes. We need to create unique code vouchers, sent to places and things like that. So now we have serverless architecture, serverless implementation doing that, and then came the critical point of data migration. Typically, when we migrate from a legacy to a modern platform, we go with this sort of mass data migration process, right? But it was challenging. We had millions and millions of customer data in SAP. But thing is, best part of the millions of records we had of or of no use, because customers either created new profiles, or customers moved on, or they're never going to come back, etc. So the question was, why do we migrate all these things unnecessarily? So that's when we came up with the on-demand migration. So we won't do any mass migration task. Instead, when a customer comes to the new platform, we will trigger off an event-driven flow behind the scenes to fetch data from SAP, update wherever needs to be updated. So that came in. It was risky, but it worked beautifully because we had challenges before a customer logged in and to move to the next stage on the site. We had to do all these things. So due to the speed of things behind the scenes, it was kind of working. Still, I think it's still in place. And then the reward profile, if you are a VIP, how do you log in and how do you access your rewards? And so there are certain kind of security related patterns and implementation behind the scenes. And then around June, the most important checkout process came into place. So it follows a kind of command query CQRS pattern. So the top line is like, okay, here is the order submission, command comes in. But then what happens is we decouple that. So there is a queue in between to soak up the kind of number of, the flow of orders. So that is because when you do the order validation, if you're an e-commerce, you know that payment providers getting through their approvals and so many things can take seconds or even minutes sometimes, because depending on the bank and the provider, etc. There's so many hoops and hurdles to go through. So that's why we simply couldn't keep the client holding on to the API. So we do that, acknowledge it. Then what they do is they do a query mechanism behind the scenes. It also helps when you have a query API, because say, for example, if the payment failed due to insufficient funds, so the backend service will receive that information from your payment provider. But we will never expose that to the front end, because if that's a fraudster, you are kind of feeding up his or her activity. So there are many such situations where this sort of separation really helps, so that service kind of filter down and what needs to. So then on July 10th, we successfully moved everything over to serverless. Everyone was panicking, expecting things to go down, and surprisingly, it was a smooth, move over, and nothing kind of broke down or anything. It was a nice experience. So that happened, and after that, the business growth, every event, whether it's a Black Friday or a product launch and things like those, everything became bigger and bigger. So nowadays, I lost kind of, keeping track of things. Nowadays, it's kind of almost every other month occurrence. Even I think yesterday, there were a bunch of products launched, spikes. You would see things like these kind of spikes, very common these days. Vertical spikes almost every month. Because back in those days, Black Fridays used to be a big one. Nowadays, it's kind of more recurring pattern. In terms of adjustments to serverless stack, virtually nothing. Sometimes they up what we call the provision concurrency in the AWS world, just to say that, okay, keep ready, 50 instances of this particular function. Whereas on the server side, on the front end side, which are run on different service, Fargate, they do a bit of scaling, but serverless kind of completely, untouched, and that's how it is. Okay, so in terms of the team growth, so I showed you this one. That was when we started. Then when we, around the time when we launched, moved everything to serverless, we still had a kind of, this setup. Remember that there are two teams at that point. So the backend, the typical backend and front end. But from there, the runway from there, it really took off. So I usually say this because the agile and iterative way of doing serverless is like a gravity-defying takeoff, because as I mentioned, there's so many things at stake when you start with serverless. It may, look daunting, but if you, persevere through, and once you got it up and running, then it becomes kind of an easy flow. It kind of, really picks up because you already have the experience, you have the processes and principles and all sorts of things. So the team now, kind of more than 20 squads, we kind of started to structure in squads. I mean, it doesn't represent everything, but you get the picture. You see more product names like, payments or loyalty and checkout and so on and so forth. So this came along and is still evolving and growing. The thing is, though we started with the LEGO.com and LEGO.com, the surrounding services, now is spreading over across to different parts. Say, for example, modernizing the customer service area. So where we are bringing in new SaaS platforms and, the data feeds and data processing pipelines. So in all those cases, serverless plays a big part because it's easy for the, engineers and us to build and take to, take the solution to production. Okay, so that happens, but how did that happen? So let's go through a few principles. As I mentioned, there are so many things with serverless. So we initially put down few guardrails to make sure that we don't kind of deviate too much beyond, making a whole mess. So we had JavaScript engineers, okay? The resource was available because, we had front end. So we decided, okay, let's do functions in JavaScript rather than looking at maybe Go or a different language, okay? Let's, at least for now, let's focus on that. So we don't kind of, so that brings complexities, training, and so many things. And similarly, framework. So framework in the sense that serverless framework, we kind of started off because easy to get going. Don't kind of experiment too much because we don't have time or the, the experience, but we will do once we, get to a certain stage. So that happened. And the other important thing that we put in place those days was the cloud account separation. What that means is like when you have a team working on a particular product, that team probably will own its own AWS account or cloud account, and they will have the developer account, QA account, and product account, not just one account with everything else with the, the staging or tagging and things like that. That makes a whole lot easier in terms of when it comes to controlling and, the autonomy and things like that. Okay, another thing, iterate you an incremental approach. Like as I've been talking so far, the approach we took was not the big bang approach. That works perfectly fine with serverless because we have plenty of event-driven opportunities. We can easily kind of bring in different services together to make things to work things in harmony. Now another thing is I think that's still in place is like fast decision making. When a team builds a service, they usually come up with a solution design, which I will highlight soon. We don't kind of spend weeks and weeks reviewing and changing and so we do the initial 1 or 2 reviews and then we quickly make a decision. Okay, let's focus on this part. Let's get going. And then along the week we can review and make things perfect if needed. There's something important. Often teams get it wrong. They try to make everything perfect, but that never happens and it never takes off. Right, so the cloud account separation I already talked about. So that is beneficial, especially when you have a number of different teams and squads they operate. If a particular squad requires a different setup of account, it gives that sort of flexibility. Okay. Serverless patterns. If you are on serverless, like any old patterns, you must be familiar with the Gang of 4 patterns. Those days when object-oriented programming and everything else was popular, those patterns still popular. There are many patterns, but with cloud and serverless, we have new patterns, right? So there are new patterns. So making use of those patterns help to kind of get solutions faster, and so patterns often associate with the problems. Like for example, I showed you the data pipeline. For us, this is a pattern because we first set up a single pipeline and immediately we were able to set up a number of different pipelines. Like I think now around 18 or 20 different pipelines. That means different types of feeds. For each feed, there is a separate pipeline in place. The advantage is that we can tune the pipeline as needed. If, say, master data update comes or price update comes, that needs to travel fast from there to here because that will impact customer journey on the website. Whereas if the feed is about, say, product review, for example, that can take a few more seconds before it reaches because it's not really going to have an impact. So these sort of the possibilities are possible. And the other one is like automation. I think automation is kind of common these days. Everywhere you have your the CI/CD pipelines and everything automated, which really kind of gives us that momentum to move things faster, which is really important, especially in the modern day when we develop with the cloud. So that brings us to a few practices. So I mentioned about the solution design approach. So this is something we insist all the squads follow. So that is basically, I mean, you must be familiar with the typical analysis and system design. This is kind of similar. So before they start implementing a microservice, we insist that they do a simple solution design. Solution design basically contains kind of a logical flow of diagram, architecture, and what are some of the elements like the data model or the event structure and any other important thing that needs to be noted down, because documents like this give the engineering clarity to the team, so there won't be ambiguous things. And also for business, when they look at the logical model of a particular service, if they are interested, they will be able to understand whether we use the C4 modeling or a different notation. Those kind of things, make it so easy. Another thing we insist on is threat modeling, especially these days when we work with customer data, payments, PII, GDPR, all sorts of things. This is really important, not just for the the DDoS attack or the other kind of security aspects. The reason we insist that is because this basically brings out ideas in a team. So when they collaborate, people when talk each other, it triggers their awareness to think something in terms of like database access, for example, for a function. If they added, say, read and write access where the function only querying data, then someone will question, why do you need to write? Why do you need the write access? So simple things like like this will be brought out. And set-piece microservice is something I kind of preach. The idea is simple. Microservices, I think most of us are familiar with. So I'm a big fan of this approach, visualizing your problem big, but when you start doing, you focus something small. How many of you were at the microservices domain storytelling talk yesterday? Yeah. Okay. So that kind of, gave a picture of how you kind of do that. It's like, the train journey or train booking as a kind of, big thing. You visualize, okay, so that's what I'm going to get. But then you start working, okay, here's the passenger, that's the ticket master or conductor, train. So you focus down, right? So I like this kind of, dialogue. I copied from the movie Mamma Mia. It's between a man and a woman. The man would say that, I think they, discuss some life, issues. They say, it's not possible. Nothing is, simple and nothing is possible. Whereas the women say everything is when you break it down. So this is basically a powerful way to kind of, tell the engineers, when you get a problem, break it down, identify an entry point. So I often give these examples like filmmaking. Filmmaking, they don't shoot the film start to end, right? So they make sequences and they can practice before they kind of go for the final shoot. Same with theater. The scenery changes, the backdrop changes, but the overall is one story they are telling, right? And same with football. That's where I from where I stole the set piece name. In English football, there's a term called set piece play, where the play happens when after a foul is committed, free kick or a corner kick and etc., they score a goal. And even when we build Lego models, so you big model, if it's a big model, you kind of build in small pieces before you bring things together. But that's fine. You may be thinking, so how does it work in serverless or microservices world? So it's simple. So if you think payments as a domain, as a single microservice, this is typically what you will see in microservices book by, I don't know, Sam Newman or anyone else talking about microservice. They talk about payments, orders, products, etc., etc. But rarely they go beyond. So in a serverless world, with the granularity I talked about, you can even break things down further. You can have a service dedicating doing the authorization and another service to do with the refunds and things. The pay by link, I think Luke will be talking about. So this is something important to get to the engineering team so they have the better auditing. Another important aspect. We have sort of certain process in place before any service goes to production. They need to go through a bunch of checklists to make sure they have everything in place. The thing is, like once they kind of practice, then it becomes part of their development process. So you don't need to kind of insist too much, especially the structured logging, alerts and alarms and all these kind of things help to have better monitoring, observability, all sorts of things. Okay, so I hand over to Luke. He will take you through a case study where his team, how they developed and how they operate a particular microservice.
Perfect. Thank you, Sheen. Thank you so much. Right, second part, the last talk on the second day. We're on the home stretch. Don't worry, guys. Got you. We're almost there. We weren't actually sure whether we were put on as the headline act or the graveyard shift, when I thought maybe everyone's gone home and at this point we'll stick those serverless guys on last and no one on my phone. I like to think we're the headline act. Little bit more about me from the intros. I've got a daughter. She's 2 years old. Hello, Lois, if you're watching at home. And it's the first time I've been away from her for any amount of time. So I sort of sat down with her before I left and kind of tried to explain, I'm going to get on a plane, I'm going to go to this other country, it's called Denmark, it's very exotic. I started drawing a little picture of a plane and I was waving and drew a picture of the conference and people in the audience. It was pretty much as full as this. And then I thought, oh, it's a good opportunity, I'll just test out some concepts with her. Started doing a dry run. Now she's just started to learn some language. She's got a few words. She says daddy, she says more, she says no. She just started to string a couple of words together. She says no daddy, more daddy. Now when I'm doing this dry run, suddenly she says, gets up, sighs and says no more daddy. So, on the one hand I was kind of crestfallen, on the other hand it was amazing that she'd suddenly strung 3 words together. So enough of that. So I'm going to jump into a little bit of a case study, as Sheen showed on that illustration there. We are the payment squad. We're called Brickcoin. Nice little, all the squad names are kind of plays on Lego. We build a product called Brickbank, which is the payments platform at Lego. That's the Brickbank set, of course you all know that. So the whole idea behind Brickbank is it's this centralized payments platform. Business units who need to process orders, request payments, they all route their requests through the payments platform, and we abstract all that complexity away. Everything around payments, payment methods, fraud prevention, we internalize all that and then communicate out the other end with payment service providers or PSPs that we've integrated with. And we integrate with a number of those. Again, the business units don't need to know too much, although there is implementation in terms of user interface. We're an autonomous squad. We build it and we run it. So obviously with a lot of power comes responsibility. We're responsible for ops, for our own accounts. We get to make tooling decisions. I'll go through a little bit of that in a minute. And we're on our own little repo, so we're kind of nice and isolated in that respect. We're made up of software engineers, QA engineers, and we have a product manager. Well, tech stack. So which of these logos brings you joy? Don't have to answer that. I know this is, there's a lot of .NET fans out there perhaps, so I was going to redact the TypeScript and Node.js, but I thought I'd leave it in there anyway. Obviously there's always going to be use cases for different languages on a serious note. As Sheen touched on, one of the decisions behind, or one of the motivations behind that particular decision for us is about talent, what's available. It's quite one of more kind of predominantly supported runtimes on AWS Lambda as well. That's kind of a big motivation. But it does the job for us. And actually, you'll be pleased to know that we write as little TypeScript as possible. We accept that every line of code we write is a line of code that we need to test, we need to maintain, that we need to operate. So the less code we can write, the better. So you'll be pleased to know there's as little TypeScript as possible in there. Obviously AWS, and these two logos here, these are infrastructure as code tools. As she mentioned, serverless framework on the left is kind of predominantly what we've used traditionally, and the CDK Cloud Development Kit is a kind of newish framework from AWS that sits on top of CloudFormation. Jess on the testing side, and I put GitHub up there. Maybe that's a bit of a given these days, but GitHub's kind of very central for us. So I'll come on to that in a little bit, and that might make. So payments at scale. Sheen mentioned that Lego mission of trying to reach out to as many children in the world as possible and get Lego in their hands and get them having that incredible play experience. And when you talk about payments at a Lego scale, we're kind of talking about scalability in terms of technology, but we also talk about localization. That's kind of what we're dealing with in the payment squad. You know, you can integrate with the primary card issuers, the primary payment networks, the primary banks, but if you're not localizing payments per market, per locale, you're going to have people who can't buy their Lego on LEGOcom with the payment methods that they're used to. So that's a really big part for us, and I won't get into the payment methods that we support or anything like that, but I think that's an important note in terms of scale. And then in terms of the technological scale, so Sheen showed those lovely unharmful spikes, which that is generally an average day at the office for us. We don't really even pay attention to those anymore. That's kind of how effortless it is. It's almost when those spikes aren't happening, that's possibly when something's actually going wrong. So this was our recent May the 4th be with you. So I just took a look at that for the purposes of this talk, and noticed that in a single minute, this was kind of the peak minute in the 2 hours on the 1st of May, we had 1,000 orders, and that was kind of consistent over about 2 or 3 hours. To Brickbank, the payments platform, we had 200,000 API requests in a minute, which is quite insane. And when we talk about scale in terms of an AWS serverless compute space, concurrent executions are kind of the metric that we measure to see how well we're scaling. We had 150 of those, which is on the high side. And another interesting one, because all the integration we do with our payment service providers is asynchronous. We get a request on the front end, we go to the PSP and say, hey, someone wants to buy something. They send an acknowledgement back, and we just kind of sit and wait patiently for the payment to be authorized. They've got to go off to the bank, someone's got to open the safe, check the money's there, and then we get back into the modern world. But so that's a really important stat for us, notifications. If we drop any of those, then we're in trouble. They're very hard to replay, and that will break the chain in processing the payment. So the service I want to talk to you about is called Pay by Link. Kind of does what it says on the tin there. You might have even used one of these already. Some banks offer that. If you've bought a round of beers and you kind of felt like someone should have paid you, you can send them a payment link and ask them to pay money directly into your account. So we use Pay by Link for telephone orders, secure method for telephone orders. Obviously, when you're building a payments platform, you're regulated by PCI and other kind of regulations. So we can't just take payment details over the phone, raw card details. So the general flow here is that a shopper would call up, wants to place an order. They call Lego Consumer Services. Consumer Services would kind of take the details of the order, the different product numbers, and calculate the total amount, and generate a payment link. Go into kind of what that looks like. At that point, we also take the email address, and then that email gets sent to the shopper. They receive the link into their inbox. If a certain time period elapses and they don't use the link to pay for the order, they'll get a reminder email, and then eventually, hopefully, they do pay for the order. So the link they receive would take them to a page that looks something like this. This is the test page, but it generally does look exactly like that in the live environment. So you've got Lego Batman bearing down upon you, kind of gently encouraging you to pay some money to Lego for that set. So you see here in the top right, this is a very, very inexpensive Lego order. It's only £1, but that amount kind of gets pre-filled there. But there's nothing to do on the user side. It's a one-time use, and it expires after a certain amount of time. I think the default's 24 hours. You'd see those localized payment methods there, depending on where the shopper's shopping from. In this case, it's just credit card, but there would be generally a few more options there. And you kind of see in the bottom right there the different statuses that a link might be in: unpaid, paid, expired. So we think of pay by link as a kind of mostly typical service that our squad in payments would build, and most of the other squads around Lego would build. And kind of go through these 4 phases, very, very traditional: design, build, deliver, operate. So that's what we'll look through today. So first, those off the top is solution design. Now Sheen did touch upon that. It's got some great blog posts around that. And when I first arrived at Lego, that was a real breath of fresh air. Such a great part of the culture there is, before we even touch our keyboards, we're taking a step back. We're defining what this feature is. It involves product management. It involves QA engineers. It involves software engineers, all talking together, thinking about this from a business point of view, from a shopper's point of view. Again, as Sheen said, we're not looking for perfection at this point. It is requirements gathering, it's architectural discussions, and it's an acceptance that it won't be the finished article, building in space for the feature to evolve and for us to observe it. So we generally have this kind of template, this structure laid out, but you can customize it, and it's fairly fluid. It needs to be structured based on the feedback, on the feature. Sorry. We kind of have this process as well, and it's mostly time boxed. But again, we say it will take as long as it needs to take. We start off with feature definition. We generally have a workshop where the product manager would kind of introduce the feature. We tend to select 1 or 2 engineers from the squad who would kind of take ownership of designing the solution. They'd create a document, and I think what we always try and do is make this kind of an iterative process and a collaborative process. Even if we have those assigned engineers, we want them to keep coming back into the squad, keep having conversations, keep bouncing ideas off one another, and then we kind of all agree in a final sort of workshop that yep, we're kind of all happy with this as a squad. We write up some user stories, write the tickets, and get that put into the backlog and eventually into the next sprint. So that's solution design. Just a recap of the pay by link journey. So what we're going to do here is to kind of think about how the build step in our phase, I'll just take each step in the user flow, and we'll look at the architecture that sits behind each step. Now, again, I know it is kind of late, so I won't go too heavy into the architecture. There's Lego Batman just reminded me to keep it short and sweet. So that first step is a new payment link requested. The consumer services generally attached to a terminal running SAP, so they'll do their thing there, punch in the order value, and that kicks off an HTTP request onto API gateway, and that's where Brickbank, the payments platform, takes over. So that's a public endpoint on the gateway, and we have a function running behind that, which is going to do the network request out to the PSP to generate the payment link. That's where the payment links are obviously actually generated on the PSP side. We store some data about that order for further down the line, and all of this is kind of event driven, right? So at that point, that's kind of that part of the service's job done. Fires off an event to say, hey, this happened at this point, and then what we'll see is further, downstream, there'll be other consuming services that are interested in that event, and they'll pick that up. So the email part. So as I said, you can see Event Bridge, which is just our event bus. That's received that payment link created event, and there's a subsequent function that says, oh yeah, I'm interested in that event. I've got a job to do, and that's send a payment link email. So we use SES to do our email sending, for better or for worse, and that email then just gets sent over to the shopper. Now there'll be different kind of feedback related to that email that we'll be interested in. Was it delivered? Did it bounce? Was it rejected by the email server? Was it opened? Were any links clicked? And we stream all of that feedback from SES into Kinesis Firehose, into our S3 bucket, and then another Lambda is going to pick up that there was an object created in S3. What was the feedback? Kind of process it. And really what we're interested in was, did the email get there or not? There's other kind of marketing data analysis that can happen around links opened and bounces and that sort of thing. But we want to know, was it received or not? And then we route those back to our event bus as events, things happening in our system. So the reason we're interested in the delivery succeeded event is well, obviously we're happy that the shoppers got the email, but we're mostly interested in it for the reminder email, right? This event, email delivery succeeded, tells us, right, a pay by link journey has now begun, and as I said, there's a expiry on those links. Let's call it 24 hours. So we want to, if after 22 hours the shopper still hasn't used that link to finish their order, we want to gently nudge them to say, hey, did you forget to finish your order? So that's where the reminder email comes in. It gets sent about 2 hours before the expiry. We use a service called Step Functions, which is essentially like a workflow orchestration service. Is running finite state machines underneath it, and that just allows us to kind of do these nice kind of sequential operations to say, hey, right, email was sent, we want to register that a reminder email will be sent at a certain point in time, but we don't want to do anything just yet. We kind of just want to sit there and wait. That's a really nice feature. That process just sits there, waits for something else to happen. And that something else could be that the shopper actually paid, or it could be that they didn't pay. So if they do pay, we just cancel that. We cancel that workflow straight off the bat. We don't want loads of workflows just indefinitely running there. So the way we know that that's happened again is that notification, that asynchronous notification from the payment service provider, that gets picked up by an entirely different service called the notification service. And again, that's going to come through our event bus into the pay by link service, and then we'll say, okay, yeah, we need to cancel that state machine. So it never gets past that wait state. And this is everything all together. So you can kind of see how things now piece together. Everything's nicely decoupled, event driven. So we'll get on to what it means to operate an application like this. Just wanted to touch on what the software delivery lifecycle looks like for that architecture, that application we've designed and built there. So mentioned GitHub off the top. So we kind of work in this kind of GitOps model, right? We treat our Git repository as the single source of truth about our application. And that a prerequisite of that is we put everything we possibly can into that repository as code, right? Seeing a lot of good nod in there, so I like brilliant. Yeah, and that comes with a few nice benefits, right? If something's happening with our application, we know where to look. We know the kind of where to look for the root cause of that. But it also means that it ties in really nicely with that delivery lifecycle, right? Like everything we do in our Git repository can trigger some kind of event. Code change, pull request review, pull request opened, all of these things, and we map those to our delivery. A line in the pay by link service, for example, kicks off the tests, kicks off the deployment, and that's that. We have all of those services deployed in isolation. And what we're really trying to do with the squad is make delivery a habit. We try any new engineer who joins the squad, we try and get them delivering within days, right? You know, we want their fingers on the keyboard, and then for them to see that code running in production within hours, not weeks, days, months, as Sheen showed way back in 2016. And a big part of that is, of course, the developer experience. What tends to be one of the shortcomings of serverless is that DX, not even limited to serverless, right? Cloud native development. Where do you test these things? Do you mock services? How do you get quick feedback loops? So we've done a lot of work on that to kind of leverage watch modes and rapid deployments. And if you're interested in some of that, that's a whole another talk, but definitely grab me and I can talk a little bit more about that. So this would be a typical kind of pipeline that we've configured on the payment link service, and you can kind of see the different steps there. So let's talk about operating that workload. The two really important things for us here are observability and security. Security is always going to be important, but particularly important for the payments platform we're talking about here and the sensitive data that we're dealing with. Let's look at observability first. Metrics and alarms. So one of the great things about running a workload in the cloud and using managed services is they all emit really useful metrics. And we leverage those metrics as much as we can to understand the health of our application. We look at the critical parts, the parts that can't go wrong or can't go wrong for a long period of time, and we monitor those metrics. And we monitor those metrics via dashboards. I'll get onto that in a little bit. But I like to think of it as like active and passive monitoring. Dashboards, kind of passive monitoring. Alarms are very much active monitoring. And alarms give us indication about kind of known anomalies with our system, right? These metrics are tracking things that we know could go wrong, have gone wrong in the past, may go wrong in the future. And again, with the alarms, we can tweak those metrics and set thresholds and use kind of time-based parameters on that. So if, for example, if you think about API request failed, you know, there could be a number of different reasons. We tend to be interested in 500 series errors there. 400 we kind of leave to the client as much as possible. But again, it could be transient. There could be transient errors in there. Maybe there's a service outage with the payment service provider, or these could be terminal bugs where we need to go in and fix something. But that's a great example of setting thresholds, right? We maybe say, hey, we got this error budget of 0.01% of API requests can fail, and anything beyond that, anything below that, you know, we're not going to get out of bed for. And if it starts to go above that, right, that's when we need to set the alarm off and go in and have a bit more of a look. Okay. Yeah, so just wanted to, I'll only touch on this one briefly, mainly to get a nice picture of a bird in, because I love birds. But synthetic traffic, and that's a canary bird. So there's this idea of synthetic canaries, you know, sending a canary down to the coal mine to see if it's safe for humans. Pretty terrible practice, but the name's apparently stuck. Not everyone likes canaries, obviously, but so the whole idea here is we send synthetic traffic into our API, and the idea there is we're gonna catch any failures, any of those alarms, trip any of those alarms before our users do that. And you might have heard things like testing in production. This is kind of what people mean. You know, there's the idea that your users can test for you, but we also use this kind of synthetic traffic. So we're generating that traffic. We can monitor this end to end, see if emails were actually received, track reminder emails, that sort of thing. Really, really powerful pattern. So if you're not using something like that at the moment, definitely check it out. There's loads of different providers for that. So onto security. So again, there's different points in this workload where we want to add additional security. One thing I'll start by mentioning is OpenID Connect, OIDC. So that's not technically deployed into this workflow, but that's what we use on the GitHub side, on the GitHub Action side, to deploy to our cloud provider, to AWS. So before OIDC, you would have used static, long-lived credentials that you generate in the cloud, paste into GitHub secrets, and they just sit there, right? And they'd be used time and time again, and they could be used for any length of time to perform any sort of operation. With OIDC, no more IAM users, no more static credentials, no credentials stored outside the cloud. You've already drastically reduced your risk profile there. Instead, you say to your cloud provider, hey, I trust GitHub, I trust this repository, I trust this workflow to perform these commands. And it's all then role-based, so they can only perform certain actions that you're in control of. And it's all session-based. So you say, hey, a CloudFormation deployment shouldn't take more than 2 minutes. So the session's only 2 minutes long. You can't go and have access to the cloud for longer than that. There's a few other things we do to secure the actual workload. We have Cognito, OAuth-based authentication behind the public endpoint. So SAP will have a client ID, client secret, and they'll use that to authenticate every request. And the little blue bot guy, that's a service called DependerBot, which kind of comes with GitHub. So with serverless compute, you don't have any of the kind of security issues around patching vulnerabilities and that sort of thing, but you are still responsible for your dependencies, of course. The DependerBot is a automated dependency upgrade tool. So we just have that running in the background that tells us, hey, there's a new version, it patches the vulnerability, and more or less completely automated deployment into AWS. Yeah, I just wanted to mention our alerts pipeline as well. That is very, very distracting, isn't it? Just want to sort of stand here and nod my head. So I think this is kind of what we talk about a lot is we want to know if something's gone wrong in production. We want to know as quickly as possible that something's gone wrong in production. And we want to be able to fix that as quickly as possible. So it's like the kind of holy trinity of our application, really. And with our alarms, that tells us that something's gone wrong. With our software delivery lifecycle, that allows us to fix that thing as quickly as possible. And the alerts pipeline is all about telling us as quickly as possible that something went wrong. And the important thing here, when you're building an alerts pipeline, you want to have as few moving parts as possible. This is not something that can fail, because if this fails, you don't know that everything else is failing. High availability, near real time, and alertception, bit of a bad pun there, but we also have alerting alarms on the alerts pipeline itself. So if things aren't going through, we've got a DLQ. Don't ask me how we received those alarms, but there you go. So this is our dashboard. So we talked about that kind of active, passive style of monitoring, and this would be the more passive side. And whereas on the alarm side, these are things that we kind of expected to go wrong, the known anomalies. The dashboard will hopefully tell us about kind of new and emerging anomalies, things that we didn't necessarily expect to go wrong. But the problem with dashboards is you can have far too much information, right? You can have access to far too much that it then becomes very difficult to spot these anomalies. So we wanted to filter the noise and just have the signal. And we use a method called the RED method, which stands for rate, error, and duration. And that's a subset of the 4 golden signals which came out of Google SRE books. You might have heard of that one. But we kind of use that method to build up this dashboard. When you talk about rate in a serverless world, you're talking about API requests. You see that big spike. This is from the May the 4th event. You see that big spike in requests. E for errors, you can see we kind of have errors in 2 places, API errors and Lambda function errors. Now that second chart, the one in the middle with the purple spike, that's API errors. There's big spike in errors, right? But we accept that because we say, hey, this 0.01% of API requests will fail. We're not worried about that. If the spike was even higher, then we might be worried and an alarm would go off. And duration is all about latency. How long did our API take to respond? How long did our Lambda function run for? And obviously latency could be down to network requests to our PSP, or it could point to an internal issue. So that's our single pane of glass into the health of our application. And there's a lot more to it. You scroll down and you've got the different, we kind of chunk it up by service. Obviously there's tons more that I could have talked about. These are some of the things that we didn't perhaps have time to cover. I think one of the most important things is continuous optimization. Sheen talked about that a lot with the well-architected reviews. But I think this is one of the things you end up focusing on a lot when you build a serverless application. You're looking at your metrics. you're analyzing your data, we're always encouraging our engineers, look at the bill, look at the costs of what you've deployed. Because those costs can point to suboptimal implementations and architecture reviews. Once we've designed that solution, once we've implemented it, it doesn't mean that the architecture is set for life. There's always things we can do to improve it, whether those are things we missed first time around, or hey, AWS, whoever introduced a new feature, introduced a new service that might fit better here. It's things like that as well. Testing strategy, another big one. Debugging, obviously with the structured logging that she mentioned as well, and we leverage distributed tracing. And documentation is another real key one. We kind of accept that we're never going to be the best at documenting things. We're never going to document absolutely everything. So we try and focus on kind of core documentation. We have this documentation as a minimum. Those are things like public API for our users of our platform. We document our release process, our delivery lifecycle, and architecture is another one we're really keen on documenting. So I'll hand back over to Sheen. Thank you.
I think we are way over time, so I won't take too long just to wrap up. So I mentioned earlier on that serverless is evolving. How do we keep up with serverless? So just a few things. So one of the important thing is like as we come from different ways of working with the previous platforms, when we move to cloud and serverless, we need to kind of have a new way of thinking and seeing things, right? So serverless is evolving, and as I was chatting to someone from AWS recently, and I thought, okay, what's next after serverless? I'm done with serverless. Let me know, what's up next. So, but he said, Jeff Barr, he said, no, we're just starting with serverless. Still, plenty of time. So that means we should be prepared for this long game. So how do we do that? So when you have a serverless team, continuous learning of, the technology, and embrace continuous refactoring. So refactoring is not old-fashioned these days. You need to keep going. And growing serverless teams, that's very important because you can't always rely on external, experts and consultants. And we have to have our own kind of, experts. So learning a bunch of ways. There are so many ways. I don't need to kind of go through the details, blog posts, talks, and newsletters, and so many things there. Refactoring, something kind of, you must be familiar from the olden days. I used to be a fan of, the classic refactoring book. But thing is, those days it was mostly around C++, object-oriented program. But these days, now with the serverless, we are looking something beyond because now we are refactoring not just the program, we are looking at refactoring the infrastructure. We are kind of rewiring things, services and things. So that's an important aspect that we need to keep in mind. And how do we justify refactoring? Refactoring, when we say, people think that, oh, isn't that a legacy term that you do once in a while, like Y2K or next Y3K, whenever it hits? But it's not the case with serverless. Serverless requires kind of continuous. So we need to kind of justify how, what it brings to the business, how it motivates the team, and those kind of things. And business goals, like, when we do a refactoring, they don't get it like I tune the API. So we need to kind of, speak in their language, say that, it kind of, brings your NPS score up. Or when we kind of, add more throughput, you need to say that, okay, it, serves more customers. So that's sort of the language they understand. And I usually give a talk on how to grow serverless. One aspect I talk about is the renewal phase. That is classically the retrospective phase. So that's an opportunity for teams to look at some of these things like refactoring, bringing in new services, and updating existing infrastructure and things like that. So bring that into your kind of development cycle. It may not be difficult. It may not be easy to put that in place, but you need to negotiate with stakeholders and to have that in place. And yeah, so have all the measures in the team so that you always have you are always on top of things. And technology motivation. So as new services come along from any of the cloud providers that you use, that kind of encourages engineers because they're not kind of, fixing bug and trying to kind of, maneuver around tangled code because they are now working with new services. So that kind of motivates them. So that sort of, things help. Also new patterns and new best practices as we find from the industry. So bring those things in. So now you find that refactoring is no longer a kind of boring term. It's more of an interesting thing. And growing at serverless engineers because they need many of the things that I showed here. That's what brings them as a good engineers. And growing the knowledge pool, the number of ways we can do with all the communication and social media presence we have, certifications and growing experts I mentioned. Yeah. So and a couple of important things. The engineers are architects. This is important, especially in the modern world. You don't always kind of work with a dedicated architect in the kind of in this world. So it is important that we grow engineers and give them the responsibility to do the design and architecture with your the backing and things. Same as the DevOps practice that Luke talked quite a lot. Okay, so that comes down to the closing stages. So as I mentioned, if you want to experiment something, you need to kind of do it because you can read somebody else's experience, but if you want to you create experience, you need to undergo it. Otherwise, there is no way of learning. So here's the recap. If you are thinking of serverless, don't go big bang. Start something small, and from there you grow. Think of all the kind of best practices and how people are doing. Learn from each other. There are community around. There's plenty of resources around on social media, conferences, and things. Help is always available. And then I leave you with this one. If you are someone new to serverless, if your application suits serverless, your organization support your serverless, take it as a slingshot, serverless technology. It really, gives you wings to, fly far and fast. That's all. Thank you so much. And we also had